Hello everyone, today I want to explain about the optical activity. What is the optically active? Optically active, it refers to a compound that rotates the plane polarized light. So, to rotate the plane polarized light, what are the conditions are required? First one is chirality required. As asymmetric carbon generally chiral. This is not mirror, non-superimposable. Mirror image to each other, but not superimposable. That is called handedness. Chirality mean what is that? Handedness. Left hand is look like to the right hand, but not superimposable on each other. That is called chirality. But keep in mind, asymmetric carbon, chiral carbon is not a necessary condition. Necessary condition is a chirality. That is a necessary condition. So to show this chirality, what is required? This symmetry element should be absent. Symmetry elements. What are the symmetry elements? One is plane of symmetry denoted with the sigma. Second one is the center of symmetry denoted with the Ci. Axis of symmetry, alternate axis of symmetry, they are also present, but mainly these two are involved in to decide the that is chiral or achiral. So you have to focus on these two characters. Plane of symmetry meaning what is that? When you pass a plane through a molecule, it divides the two equal parts. They are mirror image to each other. If it is present, mean that is achiral. If it is absent, mean that is chiral. Second one, center of symmetry. Pass a line through the center from any one of the atom or group. So that is called pass a line from any one of the atom or group through the center to the same extent to the same atom or group that divides the two equal part and they are mirror image to each other. That is called center of symmetry. So this is the a condition required. If it is present mean achiral, absent mean chirality is present. That should be the condition for the to show optically active. So now we know that rotation of plane polarized light is called optically active. If it is not rotate, that is optically inactive. So optically inactive mean what is that? Maybe achiral. Otherwise, it has a chiral carbons, but also optically inactive mean that this is optically active. Optically inactive condition also is there. That is optically inactive. That we can answer one is maybe meso. Another first one minute. So I explained already. A chiral. Second one having the chiral carbon but also due to internal plane of symmetry that meso compound also optically inactive. Third one is racemic mixture. This is called optically inactive. Then before going to about discussion of optical active, first you should know that plane polarized light. So that can be plane polarized light. Light oscillating in only one single plane, that is called plane polarized light. Sunlight or tube light or bulb light, that is propagating in the all direction, oscillating in all direction. But plane polarized light oscillating in one plane, that is called PPL, plane polarized light. So this is the light oscillating in one direction, that is called plane polarized light. This plane polarized light are two types. This is an electrical vector. This is called right circular polarized light. This is called left circular polarized light. This is the direction of propagation of that wave. So this is the direction. Then if it is right side, this is left side, then generally possible with the enantiomers. So keep in mind this is a one direction. For example, I am drawing here this is a sun, these are the lights. Then this will be propagated in all direction when it is passed through the a small slit, then through the what do you call nickel prism, then this will be propagate in one direction. This is called PPL, plane polarized lights. Next one, what is the polarimeter? An instrument for measuring the ability of a compound to rotate the plane polarized lights. So first of all, that polarimeter means it is just a device or instrument that measure the ability of compound rotate the plane polarized light. Now, this is a setup or that is an instrument. This is called light propagating in all direction. Light source this is. Then this is a polarizing filter. Through this light is propagate. Then this is a plane polarized light oscillating in one direction. This is a polarimeter tube. This is filled with a sample that having the organic compound. If it is chiral or achiral, it decide. How it decide meaning if the rotation is zero, it means not rotated that plane polarized light. That is called achiral or maybe meso or racemic mixture. Otherwise, if it is rotated, that is a right side, then some angle 10 degree, 20 degree, 15 degree, that is called dextro compound. If it is rotated left side, because this side here observer will be there. For observer, now I am writing here one, this is the eye of the observer. Then this side is the right, this side is the left. Then right side rotated meaning that is called dextro small d or maybe plus. Left side rotated means small l or minus, levo rotatory. Now, whatever the rotated that plane polarized light by the substance, that is called observed rotation. The number of degree through which a compound rotate the plane polarized light. Already shown in the diagram, maybe right side plus 10 degree or left side minus 15 degree. That is called observed rotation. Right side mean dextrorotatory, left side mean levorotatory. So what is the dextrorotatory? Refers to a substance that rotates the plane polarized light to the right side, already shown in the diagram. Similarly, levorotatory. Levorotatory refers to a substance rotate the plane polarized light to the left side. So now we know observed rotation has two types. One is dextro, another is levo. Dextro rotatory denoted with the D small d R, that is a plus. Levo rotatory denoted with the small l R minus. If it is not rotated and it is showing zero mean, in case racemic mixture cases, it rotate equal amount in both side. For example, this is a plane, observe here 0, this is a plus, this is a minus. Here minus 20 degree and here plus 20 degree. Then it rotated both side equal magnitude. That time it is denoted the DL, otherwise plus or minus. In case achiral is there, that is a 0 degree. 0 degree mean it may be meso compound or achiral compound. But racemic mixture magnitude both side equal and finally it also 0. The next term is the specific rotation denoted the alpha and square bracket. So what is the specific rotation? Observed rotation of the plane polarized light when a sample is placed in a tube 1 decimeter in length and at concentration of 1 gram per milliliter. These are compulsory. Keep in mind that unit should be in decimeter, that concentration 1 gram per milliliter. These are useful in the calculation Don't take in any other units, compulsory decimeter and here gram per milliliter. In case they are given mole per liter or mole per milliliter, then you have to convert to gram per milliliter. In case they are given centimeter or meter, then you have to convert into decimeter. That is a very important condition here to calculate the specific rotation. For a pure liquid, concentration expressed in gram per milliliter density. So I think you understood this is a specific rotation. Otherwise, I will give the formula, then you will understand. This is a formula for the specific rotation. What is the specific rotation? Specific rotation symbol is alpha and square bracket. Lambda is the wavelength of the light which is used and temperature T. This is observed rotation in the degree. Whatever that comes, that plane polarized light rotated right side or left side, that is observed rotation. And that polarimeter, already we have like this setup. This is a polarimeter. In this test tube will be present with the organic compound. This polarimeter length should be in decimeter required. And whatever the concentration of this substance, that should be gram per milliliter required. So this is a formula to calculate the specific rotation of the given substance. For example, we are taking the 2-butanol or butane 2-ol. Now this carbon bonded to the OH, CH3 and ethyl and hydrogen. Both are same butanol. One is a S and here R configuration, that is RS nomenclature, plus indicating this rotate the right side plane polarized light. PPL rotated which side? Right side, that is called, it is dextro, otherwise denoted with the plus sign. So here plus sign is there, that's why it is called dextro, right side rotated. Here minus sign meaning this is a levo, this is a levo, and this is denoted with the which one sign? A minus. So these are the same butanol, but configuration is changed. Therefore, rotation of plane polarized light is different, with the different angle also maybe are same also. So these two are called enantiomers. What do you call these are? Enantiomers. Enantiomers rotate the plane polarized light same magnitude with the opposite direction. In case separately we are discussing meaning any rotation, that is when together, that is a plus minus with the same magnitude together is there, enantiomers are together mean, that is called racemic mixture. Individual R, they are the one R compound, one S compound, but when the 1 is to 1 equal amount is there, that is called racemic mixture. That's why specific rotation value depends on the concentration also. If concentration change means that specific rotation value also change. So now together I am considering equal amount, that is called racemic mixture. That also will give as a definition now. A racemic mixture, a mixture of equal amount of two enantiomer. Now the previous one discussed example S2-butanol and R2-butanol are equal amount taken, meaning 1 is to, what do you call this, is 1 is to 1 ratio, otherwise 50% of two enantiomer, they are called racemic mixture. One is a plus, another is a minus, then totally its specific rotation, what is a 0. When it is 0 observed rotation, that is called optically inactive. So always keep in mind racemic mixture is optically inactive. So what are the inactive? One is achiral, another is meso, another is a racemic mixture. These are optically inactive. So which is active? Optically active is only chiral, when only one carbon is a chiral. This is a condition because chiral always may not be optically active. Meso compound also having chiral carbon. But which is optically active, always condition chirality. Chirality mean what is that? Non-superimposable mirror images. Next word is optical purity. The specific rotation of a mixture of enantiomers divided by the specific rotation of the enantiomerically pure substance expressed in the percentage. Optical purity in numerically equal to enantiomeric axis, but experimentally determined. So nothing but I will give the formula, then you will understand easily. If only normal discussion somewhat difficult. According to the definition, this is generally expressed in the percentage, that's when multiply with the 100. Percentage optical purity. Observe a specific rotation of the mixture of enantiomer. That is a sample. It has both, what do you call, D also, L also. In that one is pure we are discussing. Therefore, another is divided by the pure enantiomer. We have the S configuration, R configuration, or D dextro or levo compound. This is here together mixture, but here only one pure. So observe here specific rotation of mixture of enantiomer, that is a numerator, divided by specific rotation of enantiomerically pure substance. Enantiomerically pure substance multiply with the 100. Now, enantiomeric axis. Enantiomeric axis meaning what is that? The difference between the percentage of two enantiomer in a mixture. If formula may be given, then you can easy to. Then enantiomeric axis EE, percentage of R minus percentage of S. Now the example is one enantiomer is a 75%, another is a 25%. Then these are together now. Then how much enantiomeric excess meaning a racemic mixture is formed. Racemic mixture mean what is that? 1 is to 1 equal amount. So this is 75%, this is a 25 mean, which is the smallest amount here 25. So 25 of this isomer, and in this also 25 if you take that, then how much? This is a 1 is to 1 ratio, equal amount, this racemic mixture. So in this 25 subtracted mean how much left? 50. This is called excess. Therefore, this is called enantiomeric excess. I hope you understand this terminology, whatever the terminology used in the optical activity. Every word I explained with the example. If you have any doubt, you comment in the comment section. I will explain with the examples.